Risk management, class imbalance. Cultivating a strategic mindset can be summed up in one core idea: keep your eyes on the prize. However, all masters across centuries agreed that a true strategist's survival in any game depends on their ability to constantly adapt to changing circumstances. Since the only constant we can truly rely on is change, how can we maintain focus amid continuously emerging opportunities and barriers? That's where strategic risk management intervenes, to prevent setbacks or changes of plans from derailing our long-term vision. Change implies calibration, which in machine learning is conducted through hyperparameters, introduced before a model engages in its training loop. The most important hyperparameters an ML model works with are the learning rate, how big a step the model takes to improve, and epochs, how many times it reviews its data. Translated into strategic risk management, the learning rate describes how impactful an insight must be for us to integrate it into our contingency plan, while epochs describe how many times an event must repeat itself before we truly start learning from it. Hyperparameter. Search strategies. Machine learning developers can use several strategies. Random search, trying random combinations. This resembles Nassim Taleb's idea that trial and error is superior to intellectualism, since exposure to small risks builds anti-fragility. Grid search, testing every option, reflecting the experiments we run when stepping outside our comfort zone. As Machiavelli advised, always change policy gradually to avoid unrest. Bayesian optimization, making smarter guesses based on experience, echoing Sun Tzu's timeless observation. If you know the enemy and know yourself, you need not fear the result of 100 battles. Optuna, refining Bayesian with science, pushing us to explore further evidence to consolidate our insights. Just as Miyamoto Musashi encouraged, acknowledge more than one path to the top of the mountain. Class imbalance in strategic thinking. In ML, class imbalance arises when one category dominates, making it harder to learn from the minority class. In strategy, this resembles the difficulty of balancing recklessness with excessive caution. Imbalance creates hesitation, yet for a strategist, as Robert Greene warns, emotions are signals but must never dictate moves. Class imbalance can also hinder evolution. As Carl von Clausewitz observed, the enemy of a good plan is the dream of a perfect one. It may even blur the line between knowing when to fight and when not to fight, an essential distinction according to Sun Tzu. Data collection. Always consolidate knowledge of yourself and your target. Nassim Taleb warns, risk comes from not knowing what you're doing. 2. Regularization. Prevent models from being too flexible, overfitting, or too rigid, underfitting. Strategically, this means pursuing the least costly tactics. As Sun Tzu said, the wise warrior avoids the battle. 3. Resampling, balancing data by random oversampling, repeating data to balance classes, echoing Seneca's idea that constant exposure to difficulty builds resilience. Random undersampling, discarding data from the majority, like Michael Porter's warning that strategy requires trade-offs. You cannot be all things to all people. Smote, creating synthetic examples, akin to Robert Greene's advice to mentally rehearse multiple scenarios. Tomek links, removing overlaps between classes. Stripped of non-essentials, problems follow similar patterns. Like Miyamoto Musashi teaches us, if you know the way broadly, you will see it in everything. A DASYN, generating examples near misclassifications, like building clarity through bridges and negotiation. As Andy Grove said, there are no permanent enemies, only permanent interests. 4th, algorithm-level adjustments. Instead of altering data, we adapt the algorithm. Useful when datasets are too limited or resampling risks information loss. This is discernment training. Clausewitz warned, many intelligence reports in war are contradictory, even more are false, and most are uncertain. 5. Anomaly. Detection is called in the situation in which the impact of an outlier is higher than that of other classes, demanding the following strategies. One class SVM requires to never lose sight of our purpose. As Seneca says, If a man knows not to which port he sails, no wind is favorable. Isolation forest uses the decision tree logic to isolate anomalies till they become fewer and fewer, illustrating Michael Porter's observation over how the essence of strategy is choosing what not to do. Local outlier factor, comparing density with neighbors, reminding us of the fine line between bargains and wasted energy. As Miyamoto Musashi reminds is, do nothing that is of no use. Autoencoders reconstruct normal data, just like we learn to separate perception from facts. After all, as Marcus Aurelius teaches us, everything we hear is an opinion, not a fact. Everything we see is a perspective, not the truth. K-means clustering reinforces self-mastery and independence of mind. Miyamoto Musashi points out how if today is victory over yourself of yesterday, tomorrow is your victory over lesser men. 6. Evaluation metrics. In binary classification, true positives are correctly identified sensitivities, false positives are overestimations of threat. The ROC-AUC shows how well we distinguish them. Machiavelli advises, the lion cannot protect himself from traps, and the fox cannot defend himself from wolves. One must therefore be a fox to recognize traps, and a lion to frighten wolves. 7. Cost-sensitive learning. Assign higher cost to serious mistakes. Loss should never be disregarded, but this method is best when errors carry disproportionate consequences. Sun Tzu warned, he who wishes to fight must first count the cost.